Alright, welcome back to day 14 of LeetCode grind. Solf or go home. 30 minutes solf or go home. Alright, let's see what we got today. Remove all adjacent duplicates, okay? In a string. Get a string S and enter K. And a K duplicate removal consists of choosing K adjacent and equal letters from S and removing them, causing the left and right side of the delete substring to concatenate together, okay? We repeatedly make K duplicates on S until we no longer can. Return the final string after all such duplicate removals have been made. It is guaranteed that the answer is unique, okay? A, B, C, D, nothing to delete, okay, this one. First delete E, then C, and then A. Wait, no, you can't delete A. Oh, I see, okay. So, from removing them, choosing K adjacent and equal letters. Oh, it has to be K. Okay, I see. Alright. So, in that case, I think it's just recursion. Yeah, you're just recursively deleting. The problem is it even dynamic programming? I don't think. Because if you're deleting from it, it's what are you memorizing? You don't need to memorize anything. So it might just be pure recursion, right? Yeah, but the problem is, when you're removing stuff from it, each recursive loop, it's already shorter because you're removing indexes, so it should be fine. All right, let's just look at it real quick. Grab this thing. Alright, so the first recursive deletion we're looking at, this is K equals 3, I think. Yeah, so I'm looking for 3 of the same letters, I believe. Adjacent and equal letters from S. Yeah, so I'm looping D, and then I look at E, so it changed already, so, and then there's 3 E's here. So that in this context, it would remove that, and then the new string is D D B B B C whatever. Okay, so maybe if I'm just calling it, return a new string every time we remove, exit the loop, build the new string, and then just call it again on the new string. Yeah, so, it's not a loop per se. Wait. Oh, no. Okay. So, if I'm recursively sending the string, then it should be fine. Yeah. So, each string you have to loop through. Okay, and then every removal, you build a new string, and then you just pass it back to the recursive. And then if there's nothing to remove, it just returns that string. Else, it returns. What does it return else? Okay, so def helper string just call, what do we call this? Let me just call it input. Oh, that's what's it called? A term that you cannot use. What do I call it then? Input string. Whatever. Okay. So if I guess we just do a boolean. If len input string less than K. But you can return an empty string, right? I believe you can, so it should be less than, okay? Or return input string. Okay. For I in input string. Count equals 0. Starting index. Actually, we just do index and elements. Okay. Starting index goes 0. Should I just build? No, because then we want to exit earlier. We don't want to build the full list each time. It's probably a bad idea, but if I do have the dictionary pre-built with each index, maybe don't do that. Okay, so index and element. Wait, when I do Python pop, I pass in the index, right? Python array removal. I think it's pop. Yeah, pop to remove an element by the index. To remove an element. What's that remove? Oh, by the value. Yeah, we don't want that though, because then we want to pop. Okay, that's fine. Yeah, but pop is slow, so we should DQ it. Wait, what we're not popping at all. We're just, oh, never mind. I'm fine. Okay. Yeah. Okay, that's fine. Okay. So I checked. I should do like a sliding window kind of thing. So I should start my index at 1. Is that how it works? I don't think that's how it works. The enumerate syntax. Can I put 2 things here? Can I do this? Let's just print index and LA. Helper S. But it doesn't have access to K, I think. Self.k. Okay, that should be fine. Which one cannot be interpreted as integer? Oh, so you can't do this. Shit. Is there a way to start at index 1? Python enumerate start at 1. Oh, there we go. Someone knows this stuff. Iterable start. Oh, you put range in front of it. So range 1. Wait, what? Oh, do I have to cast? What the hell, dude? That's not what I want. Flex. Ah, I see. Wait, what the hell is this start for? Do I even need that? Oh shit, why did I open this? So I can just do 1 colon, right? Input string 1 colon. Wait, that's gonna no, that's fine, I think. No, that doesn't do it correctly. Wait, no, that's correct. It's just the index is not correct. Whatever. Let's just do the regular stuff. Okay, so then I'll just check. Whatever, start letter equals input string 0. If LE equals start letter there should be prep letter. If element is equivalent to previous letter, count plus equals 2. If count wait, we're not, no, it's count plus 1. Wait. It's still simpler than this. Oh my god, really? No, we. Yeah, count should start as 1. There's always one of it. Yeah, that's fine. If count equals self.k. Well, we break afterwards, yeah. Actually, can I just modify this inside? I shouldn't complain because I'm breaking, right? I don't know. String equals start index to no, it should be start index plus 2, no, plus count, no, plus Solf@k. Yeah. Wait, so if the index starts at, let's say 1, no, yeah, we can't do this. We need, okay, we need to do from, so we need the partition of the arrays from 0 to start index, and then we just add that to start index to the start index plus 2. Yeah, that's what we want, okay. What are we returning? Oh yeah, we're just returning this. I can't even spell properly. Okay, so yeah, we just keep calling this. This base case exits. But how else do we exit? We exit when there are no dupes either. That should be the second one. There's no more dupes, it should also exit. So boolean, so dupes equals false. True. If dupes call it again. Else don't call it again. And we only call this again if it's duped. Yeah, that should be fine. This is true. So it's always true unless I come in here. So it should be false default, and then I'll just set to true if it does this. Invalid syntax. Okay, what's wrong with it? What is wrong with the syntax, bro? Oh, oops, there's no colon here. So we want, yeah, the rest of the array after we plus 2, yeah. Let's do invalid. Why is that? Why is this invalid? Oh, the fuck is, oops, input string. Whoopsie doops. Now let's just print it just to see what's up. Okay, so it just does it once and there's no dupes, so it just returns it. That's fine. And what if we did this one? And 3. Turned null. Why is that? Okay, so it looks like my indexing isn't proper here. Why is the D? Oh, it removed the first D for some weird reason. Okay, so my index is improper for sure. 0 to start. Why did it remove that? Okay, let's print. Let's print this. Currently, yeah, this gets nothing. That's kind of fine. Not really. Why does it do that? Why does it remove the D? Okay, instead of this, we want like that. Is it like supposed to be like that? It might be. No, that does not work. Maybe it's input string. How does that work? Well, clearly this one didn't pull the exact amount, so it's +1 to this one. That's fine. Oh, I never set start index. Maybe that's why. Okay, so if count yeah, that's fine. Else, need an else here. And then this thing is before this. Wait, no, yeah, I'm only checking when I increase count. We set count to 1. Alright, so it doesn't look like it hits this at all now. Oh, I didn't set prev letter. Whoopsie doops. Prev letter should be Ella. What am I even using the index for? It doesn't look like I'm using an index at all. Yeah, the index is useless. Whatever. Okay, remove that. The e's, right? Yeah, that looked like that did it correctly. It didn't remove this. It did the b's, but that's incorrect because there's only 2 b's here. Why did it do that? If count is equal to self.k. Count shouldn't equal to self.k. Why did it remove the b's? So something's wrong there. Something is wrong there. Okay. What is wrong? What is wrong with this code? So apparently, okay, so it looks like the start index. Oh, the start index should always increment. What am I? Wait, no, this should not always increment. What am I talking about? Start index only increments when there's a count. Oh, it should not be plus equals 1. It should be equals to index. That's why we use index. And that's not why we use index, because it still doesn't work. Is it index minus 1? No. So if it's not equivalent, the start index should equal the next one, right? Yeah, that looks right, actually. But why is it not returning anything? Why is it null? Print dupes. Dupes is true. It shouldn't be dupes. But then this thing should have triggered. Why is it not returning this? Yeah, so input string is less than, it should return input string, which is that doesn't make sense. What's going on? Was this expecting a string, right? Yeah, why is this saying this is null? Am I returning this? Or is this just bad recursion? Dupes should be false at the last thing. Yo, what? This is AA. Wait, why is it true? Why is dupes true here? Oh, it's because of this. If element equals letter. Okay, if count equals k. If remove dupes is true, but we didn't remove anything. Hey. Wait, what? How does count equivalent to k? K is 3. What? Count should reset to 1, right? Why is it 3? What's up here? What's going on? Why is it tree and tree? That don't make no sense. That don't make sense. What the hell? Why is this AA like shifted over? Is there like an empty space in here? Is it because of this? Alright, what? Am I printing that still? Yeah, I am printing that. So, which one is that? Oh, that's... Wait, no, if it's empty plus AA, it's still empty, right? Let's put this back in. Yeah, it's still AA. That's fine. Why is it true? Why is count equals 3 here? So if I have AA coming back into the helper, if length is less than, it should have just returned. Because length is less than self.k here. Why did it not return this? It's probably this shit that's breaking it. Honestly, god damn it. Maybe if I do return like that, maybe that works. Oh yeah, that does work. I'm just stupid. Okay. Okay, let's try something else. Let's try this one. 2. That looks fine. Okay. All right. Let's see if it submits. Wonder when we get a runtime error. I don't see why I would though. But let's check it out. Oh shit! It's judging for a while. That's bad. That's bad. I'm probably gonna get a time limit exception, maybe. What? Yeah, time limit exceeded. What's wrong with this? Oh, so yeah, you definitely can't do recursion. There's probably some pattern here to delete. How do you collapse these in a way? I don't know the pattern. Oh, I'm already at 35. So I'm going home already anyway. I don't see the pattern. So here you have these threes. That doesn't help per se. Oh, we know if we loop left to right and we store the count in a dictionary, we know which ones remove. But when we remove, how do we know which way they collapse, in which direction they collapse? So we don't know that. If we have two pointers on both directions, that doesn't help much. Damn, why is this annoying? Now, what is the pattern here? How do you know? How do you know? Yeah, I don't know. Alright, I give up for now. Alright, welcome back to day 14, the LeetCode grind, where I couldn't solve it, so here's part 2. Alright, what's up?
Do you record part 2 also?
I mean, yeah, I'm recording it.
Okay, show me what you did.
It's on the stream. Check the stream. My code's up. My code's up.
Yes. Solf or go home.
Hell yeah, Solf, we go home.
Well, then you went home.
I did. I went home. I stopped at 35 minutes. I gave up.
No. It's good. Okay, so equals 3. Deed BC. Okay. Okay, interesting. So.
So basically, the algorithm is, it looks from left to right. If it finds something to remove, it removes it, and then it makes that new string, and then it sends that new string back into the recursion method until the string is done, and then it just returns.
I see. But you shouldn't need to do that. So basically, like in this approach, you can go character by character, and you can be greedy, right? So you can look at D. Is D 3? No. Is E DE 3? Nope. Is DE 3? Nope. Is DE 3? Yep. So the 3 here means that like you should just get rid of it, right?
Wait, what do you mean? What do you mean by greedy DE?
You're processing the string. It's DE DB blah blah, right?
Okay.
But what you should process, so okay, if you process the first character, what do you have?
D.
Yeah, but how many D?
1.
Okay, good. So now let's say you have a stack that stores, I have 1 D's in the beginning.
Oh, that's why you're using a stack. Oh my god, that makes so much sense. Okay. Right. So basically you loop through it, and then you put the stuff that aren't in the K into the stack. And if it's already K, you just don't add it to the stack. And you just keep throwing it to the stack.
So at each step you either add to the stack.
That's so simple. What the hell? Why is this so simple? Oh my god, I can't believe I didn't think of that. Okay. That's so simple. Okay,
it's fine.
So stack equals DQ.
In this case, you don't need a DQ. Just a normal array with.
No, but
stacks.
Stacks.
Only copying from the end and appending to the end.
No, that's a queue then.
Yeah. So an array.
Oh, so you're just using an array. You're not even using a stack.
A normal array. If you don't need to pop left, then a normal array will.
Alright, I guess that's fine. Res. Well, not res. What do you just call it? R.
You call it.
Yeah, I don't really
stack.
care.
It's a stack, really. You're popping and adding to the stack.
No, it's not a stack. It is so stack. When in a stack, if you're appending, right, and then you're popping. Oh, you're popping 0, right?
No, you're popping the tail. The last guy that came onto the stack.
Oh, okay.
It is by definition a stack if you're popping.
Wait. How do you call pop on the last element? It just pop -1?
Oh, No, just dot pop. It always pops the last element.
Oh, when you do 0, that forces it to go to the first index.
Right, which is why you want.
Oh, I didn't know pop. Oh, okay, fine. All right, cool. So we'll just stack. Okay, stack equals this for I in S. If okay, wait. When you're storing to a stack, we should store a tuple with the count, right?
Right. And so you should check if the stack has stuff.
Yeah.
If it doesn't have stuff, you should store one.
If stack, if S and I in stack.
No.
Wait.
You don't care about I in stack. For stack, you only care about the last guy, and if it's empty, right? That's all you care about.
Okay. Oh, I was okay. Visualizing this. Okay, so if you put in D.
So what happens? How do you process D?
You put it. Okay, D. There's no D in there. Oh well, I guess in your method you don't check. So you check to see if the stack is empty or not. Right. If it's empty, you put in D, 1.
Right. If it's empty at any time, you put that character on 1.
Yeah, and then you check E. And then you don't put E in because it's not empty.
No.
So you do put E in.
Put E.
Yeah.
You look at you peek the previous guy, and you're like, "Is this an E?"
No.
And if it is, then you basically
increment it. Yeah. Okay.
Right. If it's not, then you know it's a new letter, right? So you append to it.
Append to it. Yeah. Oh, then you push a new thing. Oh, append. Yeah. Okay, I see. Okay, I got it. Okay, so if stack
it's if you like Python, you can just do if stack.
Isn't that like a check on if it exists or not? That checks length too.
An empty stack will return false for if stack.
Oh really? Okay, that's good. That does in JavaScript. It doesn't do that though. Okay, that's fine.
Yeah, Python has a lot of hacks and tricks.
Okay, sure. Stack that append I and 1.
No. You mean if not stack?
Yeah, if not stack. Else stack. What is it? Dot pop. Wait, do we need to pop it to change it, or can we just peek it?
You peek it and it's the same, then you pop. If it's not the same, then you push.
Oh wait. Does array have a peek method, or you're just looking at it? You're just like -1.
Stack minus 1.
If stack minus 1 0 equals I.
Right.
Stack -1 1 plus equals 1. Right? Does that work?
Well, you can't do that because it's already there, right?
So you have to pull it out and increment it, and then put it back in.
Right. And in some cases, you will not want to put it back in. So that's,
yeah, if you have the count that you want, you just remove it. You just pop
exactly.
it.
If the
okay, I see.
Count plus 1 is equal to.
So count equals stack -1 1. If
so if it's the same element, you should always pop it, right? Because either you're incrementing it back on or you're removing it forever.
Okay, sure. I was just thinking you just peek it so you don't have to like pop it back in if it's not at the count yet, but that's fine.
Okay, I think that also works.
That's fine. We can just pop it and just put it back in. It doesn't cost much, right?
Oh no! No, you're right. You can just increment it in memory, and then but it's a tuple, so I don't know if you can do that. I think you cannot do that actually.
Yeah.
Tuples are immutable, so you should always.
Tuples aren't immutable. Okay, fine. All right. So elements. Let's do elements. No. Yeah, just element that just gets a tuple.
Well, you can do x comma y. You can do character comma count or something.
Yeah, but then you would have to create a new tuple, right, to put it back in.
No, no. You're accessing it.
So if you do this, and then you modify X, how are you putting the tuple? How do you put the
No,
tuple
you
back
don't do
in?
you don't do movement. You do that pop.
Yeah, that's what I'm saying. Okay, so if you do pop on this,
Mhm.
that stores the first tuple's element to X and for second tuple's element to Y, right? But then you still have to create the tuple again, don't you?
Yeah, you have to push back something afterwards.
Yeah.
Maybe.
So you would have to push back like X Y again back in if it
No.
doesn't
Well,
do the case you want.
no. Well, first of all, Y always changes.
Yes, I know. I'm just saying, because then you're gonna increment it. You're gonna do like Y plus equals 1, right? And then you're just gonna append the X Y back in. If it
Uh,
doesn't.
if this is no longer equal to
Yeah. But I'm just saying, like, if you left it as a tuple, you might not need to create a new tuple, right? You would just modify the tuple's second index.
No, you can't modify the tuple.
Oh, you can't at all. All right, that's fine. Whatever.
You would have to append anything.
Okay, that's fine. Okay,
I
so
believe that.
if
Not.
y plus 1 equals k, then you don't care. You don't do anything. So
Right,
it's
it should
if
be
not
Y plus one
equals.
not equal.
Yeah. Then you do y plus equals 1, and then you do stack dot append xy. Okay, so that solves that. So yeah, if you pull out E, you increment it, put it back in, and then eventually when you popped it, it's gone, and you don't care about it anymore. You just keep going,
Right.
and then you just at the end you have to convert. You just look.
You're missing something. You're missing something. You're missing the case where it's not equal to I.
Does that matter?
Yes. Oh, so what if
Oh yeah, you have to push it in.
Okay.
Oh shit, is this not indented? Probably. Okay, there we go. Else stack append I1. Okay, and then you
let's
got
put the parentheses around those.
oh yeah. And then you just loop through the stack and build the return, right?
Right.
What is the return looking for? Is a string? Okay,
Yes.
so res equals this, res plus equals I 0. Return res.
Oh,
No?
what?
What's up?
No. What about I1?
I1's just the count. Why do we care about
Yeah.
I1?
So you have to multiply it by the count.
Oh, because then if it didn't hit the 3 thing, it's still multiple of them. Yeah, you're right. You're
Right.
right.
It could be like 1 or 2 or whatever.
Yeah. So 4. J
Oh, that's right.
in.
Oh no, just do I0 times I1.
Oh, okay, sure. Okay.
Okay. Let's see.
Well, these ones all go. I guess the AA would.
Aaron.
AA run would be an edge case. Too. What?
That's right.
Then why is the output AA then? Oh, because I put 2 here. Oops. Oh, cool, nice. All right, I'll try this one.
Okay, nice. You solved it in 5 minutes.
Yeah, because of the stack. I didn't even think of a stack. I mean, I think it's also possible to do this with a dictionary too, right?
Oh, probably.
I can't believe I didn't think of it that way. If I'm just looping through it and just building the thing like that. Well, actually no. I think the stack preserves like the ordering. The dictionary might not.
And you want the ordering because
Yeah.
you want to know if you want to join shit.
Yeah. Okay. GG's. Good move.
Always. Okay. Go home when you came back.
No, this is I already failed, so it's fine.
Okay.
Now I have to append
And
these
then
two
tomorrow,
videos.
when it's good.
I said yeah. I'll probably get home around 5ish, but that's my time, so
Alright.
that's 2 your time. So whenever time you're free, around
Yeah,
that.
I'll be free. Don't worry about it.
All right, cool. Do we do the daily tomorrow, or we just straight up you choose?
We can do the daily as well.
Okay.
Um,
All right. Oh, Ken
yeah,
says
oh.
when you assign questions, he also wants the questions too, but he won't join the session because he doesn't want to lecture. He just wants to do it.
Okay, sure.
All right.
Yeah, that's fine.
Thank you.